All right, let's get right into it. We're talking about maybe one of the biggest astronomical discoveries in a long, long time, the hunt for the universe's very first stars. And guess what? Scientists think they might have actually found them. So, have we really found them? I mean, this is the million-dollar question, right? For decades, these first stars have been, well, they've been like cosmic myths, something we knew had to exist, but we'd never seen. But now, with the incredible power of the James Webb Space Telescope, that whole picture is starting to change. So let's put on our detective hats and dive in.
You know, for years, this whole search has been like a cosmic ghost hunt. Astronomers are chasing the faintest whispers of these ancient relics. And we're not just talking about any old stars here. These are the OGs, the blueprints for literally everything else in the universe. Finding them, that's like finding page one of the entire cosmic story.
And this is where it gets good. Here's the breakthrough. A team of astronomers, poring over data from the JWST, think they've spotted the signature of these so-called population 3 stars. And they found it in a galaxy way out there called LAP-1b. So in our cosmic whodunit, we've officially got a prime suspect.
Okay, so before we start checking alibis and looking at the evidence, let's back up for a second. What are we actually looking for here? What is it about these population 3 stars that makes them the holy grail of astronomy?
It all comes down to what they're made of. See, our sun is, well, it's kind of polluted. It's full of all sorts of heavier elements. But these first stars, they were completely pristine. They were forged from the only stuff the universe had lying around after the Big Bang, basically just hydrogen and helium. That's it. No carbon, no oxygen, nothing. They are the absolute originals.
And this timeline really shows you just how tough this search is. I mean, look at this. These stars lit up only about 200 million years after the Big Bang. That's a blink of an eye in cosmic history. And here's the kicker. They lived fast and died young. They burned incredibly bright and then, poof, they've been gone for billions of years. So trying to spot their faint ancient light today, it's an absolutely mind-boggling challenge.
So you might be wondering, how do they know? How can you be sure you're looking at one of these legendary stars and not just, some other really old galaxy? Well, that's where the science comes in. Researchers have basically come up with a checklist, 3 cosmic predictions that any real candidate has to match. It's like a cosmic fingerprint.
So what's on this cosmic checklist? Okay, number 1. They had to form inside a pretty small halo of dark matter. Number 2. The stars themselves had to be absolute behemoths. We're talking unbelievably massive. And number 3. They didn't live alone. They formed in small, tight clusters. If a candidate doesn't tick all 3 of these boxes, it's out. Simple as that.
Which brings us right back to our prime suspect, LAP-1b. Now, lots of other candidates have been proposed over the years, but they've all failed this 3-point check. This one, though, fell different. So the moment of truth, does LAP-1b actually line up with the predictions? Okay, let's run the check. Prediction 1, the environment. Did it form in a small dark matter halo? Yep, checks out. About 50 million solar masses, right in the sweet spot. That's a big green check. Prediction 2, massive stars. Are the stars huge? Oh yeah, anywhere from 10 to 1,000 times the mass of our sun. Check. And finally, prediction 3, clustering. Are they in small groups? You bet. Check. That is a perfect 3 for 3 match. Seriously, this is absolutely huge.
And hey, don't just take my word for how big a deal this is. The research team, in their own paper, said it loud and clear. LAP-1b is the very first candidate to ever tick all 3 of those theoretical boxes. When the people who did the work say something like that, you know it's a massive deal.
But hold on, it gets even better. There's another piece of evidence. The gas around this galaxy, the stuff just floating in its neighborhood, is also telling a story. It has almost no heavy elements, what astronomers call metals. And that makes perfect sense. It's exactly what you'd expect to see if only a couple of those first giant stars had gone supernova, just starting to, pollute the area with the first little bits of new stuff.
Okay, so the evidence is piling up. It looks like an open and shut case, right? So is it confirmed? Can we pop the champagne? Well, not so fast. The case isn't quite closed yet. Let's talk about the final verdict and what this all means for the future of the hunt.
So here's where we stand. This is, without a doubt, the strongest candidate for population 3 stars we have ever seen. But scientists are cautious. It's not 100% confirmed yet. There are still a few question marks in our computer models about how those first supernovas worked. But here's the really important takeaway.
This discovery is a blueprint. It's a roadmap that shows us how to find more of these things. It proves that this method, using the JWST and some really clever techniques, is the way to go.
And that brings us to this incredible thought from the researchers themselves. They said that LAP1b might just be the tip of the iceberg. Think about that. This isn't just about finding one thing. This could be the discovery that cracks open an entirely new way of studying the very dawn of our universe.
So that's what I want to leave you with. If we are this close to finding the universe's first stars, it just makes you wonder, what other incredible secrets are hiding out there in the darkness, from the very beginning of time, just waiting for us to build something powerful enough to see them?